Hello everybody, I will start my today another coding practice. So today in this video I will solve this question, Strobogrammatic number 2. And I actually just before this video I solved the question Strobogrammatic number 1. So in that question it was a question to write. I will be given the number and then I will return boolean if the given number is strobogrammatic or not. So that was the previous question, which was the easy category question. But for this question, this is a medium question, so probably it would be a bit more, maybe a little more, interesting and also difficult, I think. Okay, so let me get started. So this question, just like before, I copy pasted the question statement, so I will do everything in this editor. Then I will check my code works or not in the LeetCode platform later. Okay. So that being said, let me get started. So given an integer n, return all the strobogrammatic numbers that are of ranks n. You may return the answer in any order. A strobogrammatic number is a number that looks the same when rotated 180 degrees, looked at upside down. Okay, so the first thing I will do is I will check and try to understand the question statement completely. Yeah. So I will be given an integer n, and it should be more than 1. I will assume so. Yeah. Then I have to return the all the strobogrammatic numbers that the ranks n. I see. So for example, if I will be given 1, I will return say 8 or something like that. So I will return all the strobogrammatic numbers. If the number itself is strobogrammatic. And so yeah, probably it will be 1, 2, 3, 4. Oh, also 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, these. I will return it. And if n is 2, I will find such number. So 0, 0 isn't. I have to take care. But say, so 20, no, 69 and 96. And what else? Probably 1188 is also strobogrammatic. Yeah, so I can return those numbers. Okay. Okay, so that being said, I will I will define the interface. So in this question, I will return strobogrammatic num from digit or ranks n, and I will return list of that it. So that being said, I will think of the algorithm. So because I have to return all the numbers in the list, I have to. So every time I try to find the number, like 69, 96, I have to, reverse and get all the numbers one by one. So it's not just like getting the number or something. I have to literally build each number, then I have to append it to the return list, and I have to keep going. So with that in my mind, I think I can use recursion and probably backtracking. Yeah. Oh, but before that, I think the brute force approach for this question is I will check all the numbers of n digit. Say if n is 2, I will check from 10 to 99. And for each, I will check if it is Strobogrammatic or not. And if so, I will append it to the return list. And in the end, I will return the list. That's a brute force approach. But I'd like to optimize it. So, and I think I can optimize with recursion. So obviously, what I can do is I will keep track of the digit I've chosen in the list. Yeah. And also I have to take care that if I choose, say, 0, it means that the last number is determined with 0. And if I choose, say, 6, the second to last number is fixed with 9. So if I choose one number, another number is also determined from the tail. So that's what I have to take care in this question. Yeah. And also, one more thing I have to take care is I cannot choose 0 as the first element, aside from the case when n is equal to 1. If n is 1, it's okay that I choose 0 as the first digit. So that's one more thing I have to take care. So that being said, I will keep track of the digits so far, and in each recursion, definitely I will try to find number. And yeah, this should be the recursive function, and in each find method, I will append the digit here in this way. Yeah. Okay. So just for the simplicity, I will keep track of the two, array, list. I think that will make the implementation easier. So if I choose this, I will put 09 in this way. Yeah. So numbers are appended here. And as the base case of this recursive function, there are two edge cases. No, base cases. The first case is that I have to choose only one number. The other edge case is that the number of digits in these two array is exactly n. So in the former case, I will pick one number from 018. That's it. But for the latter case, I will choose 69 or 96 or 11, 11, 88 is possible. I mean, I will choose two numbers which are Strobogrammatic. Then I append it to the digits from head and tail. Then that's the end of the find method. I will build the number and put it into the return list, which should be global. Global is shared across recursive function. Then I go out of the method and backtrack. Okay, so that's it. So let me implement this. So probably, first thing I would do is build the kind of constant which can be used across this method. So I will define Strobogrammatic pair. Let me say Strobo pairs. So it should be zero, zero, 1 1. Oh, let me make it double because it should be mutable. 0 0 1 1, and 2 is not, 3 is not, 4 is not, 5 is not, 6 and 9, and also 9 and 6 is also that. Then 7 8 and 8 and 9 and 6 is already included. Yeah, so these are the strobogrammatic pairs. Okay, then I will use it in the implementation. So I will implement the find method, and also I will define the return array. This should be, global, and also I will say use digit from tail and from head. This should be also global because this is referenced inside of the recursive function. Then after defining it, I will call find method. Then after find method, returned list is appended with the answers, so I will return that list. Okay, so that being said, I don't know if this is necessary or not. I will check it later. Anyway, so in the find method, as I said, I will think of the edge case. So current chosen count. This should be so this is the number I've chosen so far. So if I've chosen all the numbers, then I will build the number and append it to the return list. So how can I raise the method? Okay, so let me define the method to create that number. So I will, define this method right there. Center num can be none. So if current chosen count is n, I will build the num here. Then I will append to the return bit. That is. And if I have to choose one more number, then I can choose is 0 or 1 or 8. So let me define one more variable. Okay, like this. So this. So I will pick 0 or 1 or 8 as the center number, and I will build the number. Then to return 0 is not. Then I will append it to the return list. Then I will return. Okay, so these are the base cases, basically. Oh, but as I said, I have to make sure that 0 is not chosen as the first, number. So my concern is that if n is, say, 2, then first 3 current chosen count is 2. No, it's okay. Anyway, so I'm talking about, yeah, this is okay because I here I'm picking the center number, and if n is 1, this should be 0, and current chosen count is, when current chosen count is 0, I will take a look at store of nums, and 0 can be here. But if n is, say, 2, current chosen count is, current chosen count is always even. So if it is 2, n should be 3. So in that case, I see center is not actually the head number, so I can choose 0. So choosing center 0 cannot be the issue here. Yeah. Okay. So that being said, I will continue the implementation. So here, I will choose the number from Strobogrammatic pairs. Then I will think of the case. I will append this and also this. Then I will call find method. I will continue the recursion. Then after coming back from the recursion, I will, reverse the change I made, and I will continue. Okay. So that's what I will do. Again, I have to make sure that 0 is not chosen here. But it can be chosen. So when it comes here, it should be n is 2 or larger. And if this, let's see. So I have to make sure if okay, so I think the most easiest way I will do is I will check it before appending it. So if alright, so no, it's not. Maybe wait a minute. Where should I do it? If it's the first recursion call, I don't want to append 0. But if n is equal to 1, I can append it. Yeah, so let me do it in this way. I decided to return this. And in that way, it is a I'm pretty sure that here no, so I can say wait, no, I have to append 0 to the head because it uses the count of the current chosen count. So probably the best way is to check it here. And also I have to take care if n is larger than 2. In this case, I shouldn't append it num, so I should array return before appending. Digit from head is 0. Yeah. Okay, so I will do this operation in line 46 again. Good. In this way, I can append 0 safely to the digits from head first element. Okay. So let me name this as a variable. Head reading invalid reading 0. Reading 0 is invalid. And I would say not reading invalid. I will append it here. I think this is much easier to read. And I will do the same here. So unchosen count is anyone. I build num here. Okay, I actually have to do this iteration. Only reading 0 is not invalid. I don't have to do it if it is invalid. Wait, I think. Oh, sorry. On my second thought, I can array return here in line 54. Yeah. Like this. Okay, so here, where is it? Digits from head append n1, append n2, and finest. Oh, sorry, so here in line 51, I mean line 50. Okay, so if, I mean, n is larger than 2, and length of the digits from head is 0. Yeah, so in this case, I'm pushing C invalid reading 0. So I will continue here. Okay, that's it. So that being said, I will write some test cases and check if my code is correct. So I will do it real quick. Oh, let me print it out, all of them. Because, yeah, numbers are, not so, okay, sorry. So let me do it in this way. Assert sorted is 018. Let me check if this really works. In line 40. Ah. Oh, I have to implement this. Okay. So I can do is so in this way, the numbers are index is taken this way. So I can find it in this way, and I will return like this. Yep. Okay, Cyberx code. In line 47. Okay. In line 75. Sometimes there's a problem. Let me print it. Oh, sorry. It should be start from 1. Center num is not defined. Oh, maybe this. Okay, assertion error. Let me check. Oh, what is this? I'm not pretty sure what this is, but at least it seems like this is 3D array. Oh, sorry, read append read. No, read append none. Okay, now it's okay. So 018. So let me quickly check the next one. So with this in my mind, it should be 1111. I mean, so 11, 88, 69, 96. Yep. Like this. Okay, good. Seems good. So I will copy this code and paste it in the LeetCode, and I will check. Oh, this. Okay, and let me move this Strobonums as the class variable. So build num is not defined. I see. So I actually moved this as the instance method. Ah, and the last thing I have to make sure is I have to return the string. Okay. So that being said, I actually don't have to do, this operation. I just have to do. So, oh, this. Okay, let me submit my code. No. So seems like, I see. One thing I forgot to do is I forgot to reverse this digit from tail. So now it works okay. But since like 1698 is included, so let me check. 1698. But the number of the number of elements is correct. So maybe building the string is something I failed. But 8881 is included somehow. It seems like 8 and 1 is chosen together. Head and tail and 1 and. Let me check which numbers are appended together. Yeah, seems like it's correct. Let me check here how they look like. When I take a look at this, seems like 1 0 is inserted together, 1 1 is inserted together, 1 9 is inserted together. Why is it so? I see. I noticed that in line 18, no, center number is not ended. So the problem is 1 and 8 are appended together. It seems to me that 1 is this one, 8 is popped out, but for this one, 1 is popped out. It seems like so. Digit from head, digit from tail. Let me confirm how digits are popped out. Yeah, so wait, 1010 Sam. Why N1 and N2 is not popped out? No, N1 and N2 is popped out. No, here I see. So if this is 00, it won't continue because it is invalid. So it should be skipped. No, it shouldn't be skipped. It's okay. 11010 is okay. And it calls find method. And what happens after calling finding method? So after find method, I see. Okay. So the problem is in the line 54 reverse method, this list is mutated. So what I should do is I should call it here in this way. And obviously I have to convert it to list from iterate. Okay, good. I will submit my code. Okay, so now it's accepted. Oh, and let me quickly talk about the time complexity and the space complexity. So for space complexity, I think it's easier to think. So I thought of the wrist, which are digit cipher and where is it? Yeah, returned wrist, digits from head, digits from tail, and yeah. Also, I have to think of the recursion stack. And because returned wrist is the returned wrist, I will put it aside. For digits from head, it can be up to n divided by 2. Digits from tail could be up to n divided by 2. And for the recursion stack, it can be up to n out of 2. So the space complexity should be O of n in total. And for time complexity, I have to build all the Yeah. Okay, so I will think how many times this recursive function is called. Yeah. So it exactly is the number, I mean n times number of built numbers, valid returned numbers in the returned list. And for the numbers in the returned list, I will assume that for each digits, so everything, if range is 6, I will have choice for the first 3 numbers. And if I choose that, the last 3 number is determined automatically. So for these 3 numbers, I will assume that there are 5 possible options. So in this way, the built number of the built numbers is 5 to the n divided by 2. So I will assume it as 5 to the n. Yeah. So basically, recursive function is called this times in total. And basically, almost all the operations are constant aside from build num. So for build num, it will, take exactly n of n because I have to traverse each number and digit phrases string, concatenated string. I can say the space time complexity should be so this is the number of recursion paths I have to do. So this is the number of recursion because 5 to the power of n is number of the built number strings. So in total, I need to call the recursion 5 to the power n times n. And for string build part only, I will take a look at line 55 and 50. In total, this should be called 5 to the power of n. And for each, it will take 5 to the power of n. So the time complexity should be this. And as I said, space complexity should be O of n, assuming that the number of digits of given n is large n. Okay. I will quickly check. Oh, seems like this is correct. So do this as n, so this is correct. And for space complexity, seems like bigger. Oh, probably because this includes the returned list. Yep. Okay, so let me quickly. Oh, so this is iteration. I see, not backtracking. So maybe space complexity is different. But anyway, let me wrap up my today's practice. So in this video, I solved the question Strobogrammatic number 2. And in this question, I will given integer n, which represents the digit number. I mean, number of digits. And I will try to create the problem all the strobogrammatic numbers whose number of digits is given n, and I will return the list of all those numbers. Yeah. And for the implementation, I use the recursion with backtracking. And I initiated the list, so which are returned list, which is I mean the list of all the numbers, which means the condition. And this is global across the recursive functions. And also I initiated with digit from head list and digit from tail list. And every recursive function, I push the chosen number into this list. And I continue the recursion. And then as the base case, if I find that the chosen numbers is number with the chosen numbers is enough, then I finish the iteration, so recursion there, and I will append the number, which is Strobogrammatic, to the global return list. Yeah. Then after the recursion, I will return the read list. Okay, so I will finish my today's coding practice with this. Thank you so much. Bye.